All right, here we go. Quadratic functions, lesson 5, applications of quadratic functions. So this actually gets used quite a bit in different ways. And so we're going to go over one way of doing it together, one problem together, and then it's up to you to put it into practice elsewhere. So first off, we have this thing, Mingung. A punter for a football team kicked a football whose height of the path of the football can be modeled as a quadratic function of time. So the reason that they say it like that, quadratic function of time, is this is the quadratic, pardon me. This is the quadratic function of time, which means the t that's in here is time. Okay? So, where t is the number of seconds, this is important, which have elapsed since the football was punted, and h of t is the number of meters. That's also good to know. Above the ground after 2 seconds. So use the feature of your graphing calculator to sketch the graph of h of t above ground. So your t is going to be your x, obviously, and your h of t is your y. So go ahead and put that in your calculator. Pause me. And you should get something that looks like this. Now, using your maximum value, go ahead and find your maximum value here. 1.4, 1.44, 1.5. Ooh. 2. I think it's 12.25 at 1.5 seconds. You should do your max for that and find out what it is exactly. Okay. Determine the maximum is, what did I say? 12.25, I think, meters. Determine the time it takes for the football to reach its maximum. So that is your x value. So x was equal to 1.5 seconds. Determine the height of the football above the ground as the punter makes contact with the football. So let's have a look at that, shall we? What we're going to notice is at 0, okay, I'm going to just scooch in here for a second. At 0, when x is equal to 0, that's when it's getting punted. It's actually 1 meter above the ground. It doesn't start at 0. So 1 meter above the ground. Determine the height of the football above the ground at 0.5 seconds. So that's when x is equal to 0.5. Let's see here. 0.5. 7.25. To determine after how many seconds to the nearest tenth, the football is 10 meters above the ground. Pardon me. So this is when your y is equal to 10. So when your y is equal to 10, oh goodness, it's not letting me do it, is it? But I think the reason for that is because 0.83, 0.83. Okay. I can make this y equals, what was it, 10? So when y is equal to 10, you're going to notice that it comes through here, 8.4, and also 2.17. So it actually goes up and over, right? So you have a point here and a point there. 0.83 and 2.17. Explain how the answers to 1, 2, 3, and 4 can be determined from the function. So this is your A. This is your H. This is your K, right? And HK tells you your vertex. So maximum height is going to be your K value of your vertex, your Y value. Determine the time it takes to reach the maximum height. That's your X value, right? So here's your thing. You're going along here. This is your time. How long it takes you to get up to that top value, that's your X value. So 1.5 seconds. We know that from this should be 1.5. Determine the height of the football above the ground. I don't think that was one that we needed to figure out. Oh yeah, it was. Okay. So I was trying to figure out what this point was when it went over the graph, what the top value was, and I would make x or t equal to 0. So -5 times 0 minus 1.5 squared plus 12.25. You stick that into your calculator, should be able to, that should equal 1. Okay? Because when time starts, x is equal to 0, right up here. And that's the point where we need to figure it out. The punt is not caught by the opposing team and the football hits the ground. Determine how many seconds to the nearest hundredth it took the football to hit the ground. So now I'm looking for when this graph hits the ground right here at 0. So when y is equal to 0 or the x-intercept. Okay? So if I go back here, your x-intercept is... Come on, give me the x-intercept. Oh, yeah. Fine. I can put it in here. If it'll let me. And it's not going to let me. X is equal to 0. .0652. So probably 3.1 is what they're looking for. To the nearest hundredth. Oh, pardon me. To the nearest hundredth, tenths, hundredths. So 3.07. Okay, so all of this is all about figuring out what those numbers mean, what your x is, what your y is. Okay, so this is time in seconds, and this is height in meters. Okay. And if you think about the height of the ball, if it's starting here and going up and over and down, this is when it touches the ground again. This is going to be your starting point at 0. This is going to be the top height of it. Okay? All right. So now the rest of these assignments, that's what it's all about. Figuring out what your X and your Y are. So go ahead. That's it.